Everybody, how you doing? Welcome back to another edition of TallTal Presents Rock Stars in Math and all the cool things. Today we're going to talk about one-step linear equations. I have a video on modeling one-step linear equations, which really sets the groundwork for understanding how this whole process works and getting a visual picture of it. Now we're going to go more into the specifics on how to solve one-step linear equations. Hey, do you know what a Frisbee's favorite kind of music is? Disco. 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 Probably should have changed that music to disco music. That would have been really cool. All right, let's get rolling. Again, we're going to talk about solving one-step linear equations. We're going to be applying what we know about real numbers. And we're going to be able to confirm if our answer is right or wrong, which is kind of a cool thing. Like, you don't need me to check it. You can check it on your own. And we're going to get into that. All right, so inverse operations. This is our vocabulary right now. Inverse. What does inverse means? Well, inverse means the opposite or the reverse operation. So in other words, if you're adding something, what's the opposite of addition? That would be subtraction. So addition and subtraction are inverse operations. They are opposite of each other. Same thing with multiplication and division. They are opposite of each other. We're going to be using that word inverse a lot when we start thinking about equations. Okay, so if you've seen the last video on modeling, you should know that when we talk about equations, we're talking about equations looking like a balance. So what that means is on one side of the equation or on one side of the equal sign, and on the other side of the equal sign, they have to represent the same thing. They have to have the same value when they're done. In other words, if we want it to stay balanced. So if we know that, whatever we do to one side of that equation, we have to do it to the other side of the equation if we want it to stay balanced. I can't put 5 pounds on one side of a scale and expect the other side not to shoot up. Okay? So that's really important as we go forward. Now, let's go forward. So when we're solving equations, here's 3 things I want you to think about when you're solving an equation, these basic ones, these one-step equations. First thing is we're always trying to get the variable by itself. The variable is going to be the letter in these equations, and we want to get it by itself. So at the end of an equation, or I'm sorry, at the end of solving an equation, we want to be able to say something like C equals 4. We want to get this by itself. So once it's there, then we'll have an equal sign. This side will be the answer. So that's the key. Next, when we're looking at an operation and wherever the variable is, we want to see what is happening with that variable. So what operation? When we say operation, what we're saying is it is the variable being multiplied, divided, subtracted, or added. So in other words, if we had C plus 3 equals 7, we're asking ourselves on the side where the variable is, what operation is taking place? And in this one, it would be addition. Okay? And so then once we know that, whatever that operation is, we're going to use the inverse of that operation to get the variable by itself or to move the terms and the coefficients to the other side. All right, that's the basics. I'm going to put that at the top of each one of these as we try a couple. So here's an equation. X minus 8 equals 10. And here's our 3 things we want to keep in mind. 1, get the variable by itself. At the end of this, I want to see X equals something. I want to get it by itself. Second, what operation is involved? All right, so where's your variable? It's right here. What is it involved with? X minus 8. It is dealing with subtraction. Okay, so now we know that. And third, what is the inverse of that operation? Well, what's the inverse of subtraction? What's the opposite of subtraction? Well, it is addition. So now we know how to solve it. X minus 8 equals 10. What's the opposite of subtraction? Addition. What's the opposite of negative 8? So we want to move it to the other side, okay? We want to get rid of that 8 and move it to the other side, negative 8. So we're going to do the inverse operation. In other words, if you remember from modeling, what we're doing is we are creating 0 pairs. So if I have X minus 8 and then I add 8 to it, those cancel out because a negative 8 and a positive 8 is 0. So now I just move my X down, right? Because I got rid of the negative 8. And then on the other side, what is 10 plus 8? 18. All right. Why did I do positive 8 right here? Because this was subtracting 8. And why did I do positive 8 over here? Because whatever I do to one side of the equation, I have to do to the other side of the equation. And so once you cancel that out, negative 8 and a positive 8 is 0. And then you add your 8 over here, you're going to get x equals 18. So let me show you something real quick. I'm going to write this down again, x equals 18. To solve, to make sure this is right, I'm telling you that x equals 18. So let's put in an 18 where the x is, and then let's subtract 8 equals 10. So in other words, I just substituted the 18 in for that. What is 18 minus 8? Well, it's 10. And does 10 equal 10? Yes. Then I got it right. All right, let's try another one. Okay, the next one says x plus 2 equals 6. All right, so what are our things we want to look at? The basics. One, we want to identify where is the variable. Okay, I want to get it by itself. So I want to get that x by itself. All right, what operation is involved with the variable? This one says plus 2. So we know it's addition. We have a positive 2. And then we're going to use the inverse operation to get that variable by itself. Well, this one says x plus 2 equals 6. What's the opposite of plus 2? That would be minus 2. All right, now I got to subtract negative 2 from this side of my equation, which means I have to do it on the other side as well. Otherwise, my equation becomes unbalanced. What is 2 minus 2? Well, that equals 0. So this side cancels out. And x equals, what is 6 minus 2? 6 minus 2 is 4. Let's check our work to see if it makes sense. Let's go back and plug in our 4 where that x was. So 4 plus 2 equals 6. What's 4 plus 2? It's 6. 6 equals 6. We are correct. Okay, so for the addition problem, we use the inverse operation, which is subtraction. The last problem was subtraction, so we use the inverse, which is addition. Oh, look at this one. Now we're going to do the same thing, but we're going to use the inverse operation to solve it. Okay, so we have one thing I want you to notice is I wrote this equation backwards because I want you to understand it doesn't matter. The g doesn't, or the variable doesn't always have to be on one side. So when I solve this one and I want to get the variable by itself, it's going to look like this. G equals something. Okay, doesn't matter which side of the equation it's on. Secondly, what operation is involved? Well, when a number is right next to a letter, that represents multiplication. Okay, that represents multiplication. So what's the opposite of multiplication? That would be division. So how do we divide? We can show division in a couple different ways, right? We can do this. Okay, we can do division that way, but one way we do it here in algebra is we use the division that looks like a fraction. So if this is 3 times g, what's the opposite of multiplication? Division. So I'm going to divide 3 by 3. Okay, oh, I did divide it one side by 3. What do I have to do the other side? I have to divide it by 3. Now I'm going to expect you to be showing your work when you're doing these type of problems. I have to see, the teachers want to see how you're solving these problems. So what is 3 divided by 3? It's 1. So 1g is what I have left over here. And what is 24 divided by 3, or 24 broken into 3 groups? That would be 8. If I have 1g, do I have to write 1g? No, I just write g. G equals 8. Okay, so if you notice in addition and subtraction, when I was subtracting and making a zero pair, I crossed it out and said it canceled it out. You can do the same thing here too. You can say 3 divided by 3 cancels out, and that just leaves us with g, and this would be your final answer, if that makes sense. But let's make sure we're right. We said g equals 8, so let's write our problem over again. 24 equals 3 times g. What does g equal? Well, we think it equals 8. So what is 3 times 8? It's 24. Does 24 equal 24? You bet it does. This one is correct. How about this one? B, anything written in a fraction form, it can also be written as division. So b divided by 4 equals 7. So what are we going to try to do? Get the b by itself. What operation is being involved with that variable? B divided by 4. It's division. So now we want to do the opposite of division, which is what? Multiplication. Now in algebra, you're going to stop using x as a way to show multiplication because most of the time, the variable we use is going to be an x. So in other words, we can do a couple things. We can do a couple different things here for it. We can use this little dot, which means multiply. So we're going to multiply, we're going to multiply b divided by 4 times 4 to do the opposite. Or you could do times 4. You can put something in parentheses and put it right next to something. I always just like to use the dot as much as I can. I think it works the best for me. So I would say we're going to multiply this times 4, which means on the other side, we have to multiply it by 4. Okay. And so remember that cross when we're about to multiply fractions. So 4 can be also written as 4 over 1. And when I told you before we multiply anything, look diagonally and see if you can simplify anything. So 4 and 4 can be simplified to 1, can't they? So then we'd be multiplying 1 times b is b, and 1 times 1 is 1. And we would get b over 1. We would get b over 1. What is b over 1? All right. What is b over 1? Well, that's equals to b. Anything over itself is just 1. So in other words, what I'm trying to tell you is when you're doing the inverse operation and you do this, you can just simply cancel it out because you're doing the opposite operation, which is going to get us to 1. So b equals, what is 7 times 4? 7 times 4 is 28. Let's check it. Let's write our equation over. B, we're saying, equals 28. What is 28 divided by 4? 28 divided by 4 equals 7. 7 equals 7. We are correct. Gosh. Inverse operation, one-step equations. Okay? Oh, tricky time. Tricky time. Well, this isn't tricky. It just makes sure you understand if you're dealing with fractions, how you're going to solve this problem. Well, what are the rules? The first rule is we want to get the x by itself. All right, here's our x. And then we say what operation is involved. We have 1/3 next to an x. So that means it's multiplying, all right? So what's the opposite of multiplying? That would be division. So if I'm going to divide 1/3 by 1/3, what am I really doing? I'm taking 1/3, I'm switching this to multiplication, and I'm flipping the other one over. So I'm really multiplying by its opposite, by its inverse. So if I do that, I'm going to say, let's multiply this side by 3 over 1, which means we have to multiply the other side by 3 over 1. Okay? Remember what I told you with this one? When we look diagonally, they cancel out. So whenever you're multiplying or dividing by the inverse, you can just cancel them out. So now we know x equals, what's 4 times 3? It's 12. And what's 1 times 1? It's 1. So what's 12 divided by 1? Would be 12. X equals 12. Can we prove it? You bet we can. We're saying x equals 12. X equals 12. Or x equals 12. It doesn't matter. So I go back into my original problem. I say 4 equals 1/3 times x, which we're saying is 12. What is 1/3 of 12? Well, if you do the multiplication, it equals 4. 4 equals 4. And that is a big old check marky. So we know how to solve these. All right, so solving, let's fill in the blanks. Solve one-step equations. First of all, what is an inverse operation? An inverse operation is the opposite operation, okay? It's the opposite operation. And so I want you to write addition, and then you could put and subtraction are inverse. What else is? Multiplication and division are inverse. So you'd fill in that blank. Next up, we have, what is the goal of an equation? Getting the variable by itself. Getting the variable by itself. And how do we do that? We ask ourselves, what operation, meaning is it multiplying, dividing, subtracting, or adding, is being done to the variable? And once we figure that out, what do? Then we do the inverse operation to solve the problem for a one-step equation. When we get into two-step and multi-step, you'll have to do this inverse thing multiple times. But for this unit and for this assignment, you're just doing it one time. All right. I think you guys are ready to rock and roll. You've done modeling, and now you've got to see how it works without using the models. So why wouldn't the worm buy anything new? It was dirt cheap. Worms live in dirt, and they're cheap.